In this video, we are going to review atomic notation and Bohr-Rutherford diagrams. To begin, we need to look at atomic structure. Atoms are made up of electrons, protons, and neutrons. So just quickly reviewing, an electron has a -1 charge. Typically, we write E with a negative sign as a superscript to denote that we have an electron. A proton has a +1 charge. Typically, the symbol we use is a P with a plus sign. And finally, a neutron has a neutral charge, and we use N with a superscript 0 to denote a neutron. Looking at the masses of each of these types of subatomic particles, what you'll notice is that a proton and a neutron have relatively the same mass, and an electron is a much smaller mass than both a proton and a neutron. So an atom's mass is made up of mostly its protons and its neutrons, and the electron contributes very little to the mass of the atom. In terms of radius, a proton and a neutron are relatively the same radius, whereas an electron is much smaller in size. Now, when we're looking at the masses of atoms, it's not very convenient to use grams because we would end up having to write out the masses in scientific notation all the time, which is not very useful. So instead we use something called an atomic mass unit, which is shortened as U, or sometimes you'll see AMU. You could use either or, they are interchangeable. And this unit is standardized to the mass of a proton. So 1 U is equal to 1.67 times 10 to the negative 24 grams. And so U's are a lot more convenient, or AMUs are a lot more convenient than measuring in grams. And so that is what we will do when we're talking about masses of atoms. Now we need to review what the atomic notation is. So typically when we write out an atom, we have the element symbol. An example might be, say, silver. And then the atomic number, Z, we write down at the bottom. So the atomic number for silver is 47. And the mass number, so that's the mass, is written at the top. For silver, it's 108. Now, if you look on any periodic table, what you're going to notice is that the mass number is not an exact number. What you want to do is round off to the nearest whole number for your mass number. And we'll go over why these numbers are not exact in the next video. Now, the atomic number and the mass number gives us lots of information about our element. So the atomic number is equal to the number of protons in the atom. And the number of protons is equal to the number of electrons if we have a neutral atom. The number of neutrons we can find by taking our mass number and subtracting our atomic number. The difference between those two gives us the number of neutrons. And finally, then, that means our mass number is the number of protons plus the number of neutrons. Okay, so our atomic number and our mass number gives us lots of information which we're going to need to figure out how to draw our Bohr-Rutherford diagrams. To review Bohr-Rutherford diagrams then, we're going to do two examples. We're going to draw the Bohr-Rutherford diagram for a chlorine atom and for a magnesium ion. Now it's really important that you pay attention to when I ask for Bohr-Rutherford diagrams, whether I'm asking for an atom or an ion, because they are going to differ slightly. Starting with a chlorine atom then, if we look on our periodic table, our chlorine atom has an atomic number of 17 and a mass number of 35. So before we can do our Bohr-Rutherford diagram, we need to figure out the number of protons, neutrons, and electrons that this atom has. Recall, our atomic number gives us the number of protons, so that means we've got 17 protons. Our number of neutrons is our mass number minus our atomic number, so 35 minus 17 gives us 18 neutrons. To find the number of electrons, because it is a neutral atom, it says atom, it doesn't say ion, it means that the number of protons is equal to the number of electrons. That means that we've got 17 electrons in our chlorine atom. What we're going to do then to draw our Bohr-Rutherford diagram is we're going to put our protons and our neutrons in our nucleus, because that is where they're found. And then we're going to put our electrons in the orbits. Remember, in our first shell, we can put 2 electrons. So we're going to just draw those in there. Our next shell fits 8, so let's put 8 in. Now I pair them up, but as long as you have 8 within that orbit, I will accept that diagram. There is a very good reason why they are paired, but you will not learn that until grade 12 chemistry. And so now we've got 10 electrons here. We need to place 7 more. So the next orbit fits 8, which means we can draw our 7. So we got 6 there and 1 here. And that is our completed Bohr-Rutherford diagram. Now, just a note, you can draw Bohr-Rutherford diagrams using a shorthand notation as well. So what that's going to look like is we'd have our 17 protons and our 18 neutrons again. And then instead of drawing the full orbit, you can draw these half orbits like this. And instead of putting all the electrons on, we just write how many electrons are in each shell underneath each one. So the first one has 2, the second one has 8, and the last one has 7. So you can do the shorthand notation as well, and that is okay. All right, so our magnesium ion. Magnesium is atomic number is 12, mass number is 24. So that means magnesium has 12 protons. Let's put that in the center there. It has 24 minus 12, or 12 neutrons. And now to figure out the number of electrons, we need to pay attention because this is an ion. Magnesium, when it's an ion, you have to recall, will take on a 2+ charge. That means that there are 2 more protons than there are electrons. So to get the number of electrons, what you need to do is take your atomic number minus the charge. So in this case, we're going to do 12 minus 2, which gives us 10 electrons. So we need to put 10 electrons for our diagram here. We're going to put 2 in our first orbit. We're going to put 8 in our second orbit. And then that's 10. So we're almost done. The last thing we need to do, because this is an ion, is put square brackets around our diagram and put the charge outside. And that indicates that that is an ion. If you were doing the shorthand version, I'm not going to write in all the numbers here, but you would do the shorthand version and then draw square brackets around that with the charge as well.